one reality that happens in statistical analysis is what we call error. Okay, and this is something that we're trying desperately to control for. And we have two major groupings of errors. We have sampling errors, and we have non-sampling errors. Okay, so we're going to kind of build this into two groups. Okay, under sampling errors, we can have a randomization issue. So this is the question of, this is a group where, or sorry, we can have a non-randomization issue. So here, if I have been sufficiently randomized, okay, so I used some effective way of randomizing things, I still can have error because I can create a random group, right, take a random sample, and still have that sample be not representative of the population. So it is possible for me to take a random sample of all Olympic athletes and only get basketball players. That would be an awful thing, but this would be a sampling error. So though I have sufficient randomization, there is a discrepancy here because there's this, the sample results will not mirror or be statistically, there'll be a statistically significant discrepancy between the sample results and the population results. If that happens, that means that I've sufficiently randomized my group, but the random sample that I chose is not representative of the whole. Usually the way you mitigate this error is by trying to replicate the experiment and look for some sort of central tendency, but ultimately this error can occur. Okay, so the second thing that can happen under sampling errors is something where we're just not sufficiently randomized. So something went wrong in our randomization process. Okay, usually this happens if there's some sort of voluntary response or some sense of aspect of convenience in our sampling. So you may have sent out a letter questionnaire to every student in the upper school, but your questionnaire might have 57 questions in it, and only the students, or you might have sent it to a random subset of the school. So we still have the random there, right? But only certain students returned the thing, so this is their voluntary response aspect. So you may have picked a random sample, but you know what? People might have blown it off, or they might have turned it in incomplete. So here, you're still not getting the randomness back. You're getting people who have decided that, hey, I'm going to do this whole survey because this is really important to me, and it's going to throw really big bias into things. So you might be able to demonstrate that you chose survey respondents at random, but you may only be getting good data from a small portion of that random group. So ultimately, the randomization that you did just got wiped out. Okay, so if there's a voluntary response aspect or a convenience aspect, it doesn't matter how random you have made your group, it's still going to come out as a not sufficiently random response because the voluntariness or the convenienceness of this has wiped out your randomness. Okay, so here I can have something be sufficiently randomized and just accidentally get the wrong group. Here I could have had some aspect of my experiment or my observation that wipes out the randomization that I thought I did, and now I'm just I'm getting bad information in my sample. Okay, so these are things that are sampling errors. Like the sample does not represent the population, either because even though I was sufficiently randomized, I got a bad draw, or I was not sufficiently randomized and I interjected something like a voluntary response or a convenience response into the mix, which wiped out my randomization. Okay, so non-sampling errors. These are just basically human errors. These are errors that are caused by human actions. Okay? And there's a whole host of things that people can just do wrong. Okay, so these are what we tend to call human error. Okay, so let's make a brief list of these. You can have bad data entry. Somebody could be typing data into a computer, calculator, whatever, and just type in the wrong numbers by accident. You can have bad computations. Okay, this is just like a mathematical error. Something that where somebody divided when they should have multiplied, something like that, that'll throw off my data completely. You have biased questions. Okay? The example I think we gave at some point in all of this was like, do you think we should deport Hispanic immigrants in order to preserve American jobs? I mean, that's a biased question. It suggests that Hispanic immigrants are stealing American jobs, and I don't even know how that even works, but that is like a question that leads you to a conclusion, and that's going to cause error in your results. Ultimately, do you think we should deport Hispanic people is a very different question than do you think we should deport Hispanic people in order to save American jobs. So this is going to bias your results. The respondents can give false data, okay? It is not uncommon that if you ask somebody, even something as simple as, how much do you weigh? They're not going to give you an honest answer. So finding ways to mitigate getting false data from respondents is an important idea. Forming biased conclusions. Okay, so this is something that's really tricky. Like, it is hard for researchers to look at data sets and not bring their own bias into it. So this is one of those things where you can have the best sampling done in the world. You can have the best safeguards in there, and once you get the data, the researcher's bias enters into it and draws conclusions that aren't necessarily supported by the data. And finally, you can use the wrong statistical method. Okay, so something might best be served by using like a randomized block design, and you choose to do a twinning experiment. Or something could be best served by using something like a sampling method where you're doing stratified sampling and you use clusters. So you always want to try to figure out which statistical method is going to get you the best possible results from your work. Okay, so we said a lot here. Let's recap. Okay, so there are essentially two types of errors: sampling versus non-sampling. You can either have a sampling error where you have sufficiently randomized your sample, but you end up with a non-representative group just by bad luck. You can also have a situation where you have not sufficiently randomized your sample, and this could be simply because you just didn't sufficiently randomize, or it also can be because some sort of voluntary response or some sort of convenience response has wiped out the randomization work that you did, and now you're going to get a non-representative sample because though you've tried to do the work of randomization, the aspect of voluntary response has undone that, and you've gotten just a specific portion of the population. Okay, non-sampling is human error, so you can have bad data entry, you can have bad computations, biased questions, false reports of data. How much do you weigh? Can you be honest about that? I don't know. Me, probably not. You can have biased conclusions from good data. That happens all the time. It's kind of like reaching the conclusion you want, even though the data might suggest otherwise. Or you could use the wrong statistical method for the situation. Okay, so there's a recap of this section. Thank you.